Okay, welcome everybody again to the Joy Track, and fresh welcome for those just joining us. If you're joining us on Zoom, please feel free to post any questions using the Q&A option as part of your client, and I'll be asking those to Petra at the end of her talk. If you're on Twitch, I am trying to monitor the stream chat there as well, so please feel free to post questions there. At the end of the talk, there will be a link posted in the chat on Zoom to the breakout room where Petra should be joining afterwards for you to have a bit of a more interactive Q&A session. And now it's my pleasure to introduce Petra to you. She's the last of our talks for the morning track, and Petra first heard about Scala more than 10 years ago, and after that, it soon became her #1 favorite language. She's very interested in DevOps tooling and improving developer productivity. For the last 3 years, she's worked in distributed teams and strongly believes in remote working. And today, Petra's going to talk us through MUnit, the new testing framework on the block. So over to you, Petra.
Okay, thanks a lot, Chris. I'm super excited to be speaking at Scala Love Conference. And this is my first time giving a fully remote presentation, which is, yeah, a bit different to not being able to see you guys, but I hope it will be, everything work just fine. So I'm happy to introduce you to a new testing framework that's called MUnit. And you might be thinking, great, a new testing framework, but there is already a couple of testing frameworks out there. So do we really need another testing framework? If we look at Scala over the last 10 years, so there was this, in the very beginning, there were no Scala-specific test frameworks, but then quickly there came Scala Test and Specs 2. So those two have been around for most of the time. They are both quite, yeah, proved to be working well and have a lot of features. And a little bit later, there came two other frameworks, Minitest and Microtest, that were like more opinionated, didn't offer like trying to squeeze in all kinds of features, but had a very specific philosophy and tried to be more minimal. And lately there has also been Scala Verify, that's another minimalistic framework that's actually based on Minitest. And its goal is to have like a common minimal testing library that can be used to test on Scala itself. And in the beginning of this year, a new testing framework has been released. It's called MUnit. And some quick facts about it. MUnit has been created by Olafur. It was released in the beginning of this year. You might also know Olafur from several other Scala Meta projects. And MUnit is also used in some of those projects already. So it's used in real world projects. And its name comes from the fact that it's a member of the Scala Meta family. And most projects of this family start with the letter M. Let's get a quick overview of its goals and features. We will dive into more details later. The first and most important feature, in my opinion, is that it treats tests as pure values, and it has a minimal and developer-friendly API. It really encourages you to customize it and make it your own. It has extensive support for filtering, both statically or on dynamic conditions. And there's quite a lot of interesting things that you can do it. And one of them is transforming your test cases or values before they actually run. And it gives you actionable errors, which is like a nice test output that should make it easy to spot a lot of errors right in the command line without having to navigate into your code. And I'm sorry, my neighbors are working. I hope it's not too loud. So another set of important goals is to support the whole Scala ecosystem, like Scala.js and also Scala native. And it's already available for .t. It's implemented as a JUnit runner, and so for this reason it has good IDE support. And yeah, one of its goals is to leverage existing tooling that's available for JUnit. And it also provides reporting based or a reporting that's based on a SBT plugin, and lately also support for Scala check has been added. So let's get a quick look at how writing tests in MUnit looks like. So that's the correct slide. If you have used other test frameworks, so the setup for MUnit is pretty similar. You basically just have to add a dependency and declare it as a new test framework in your build SBT. And writing a simple test, the most straightforward way to start is by extending MUnit fun suite. It's also possible to go for a more minimalistic approach, but I guess for convenience and getting started, this is like the best way to go. FunSuite gives you a clean and quite minimal testing framework that can be used without learning too much about the underlying implementation in the beginning. It comes with a lot of features included, and it should cover most of your testing needs. So most of the things that you will see in this example with some things that you probably know from other testing frameworks. So MUnit comes with a very simple API to let you declare test cases. And out of the box, it already supports synchronous and async values. Other things that it lets add you with traits is assertions and fixtures, and transformations for suites and tests and values, as we will see later. So like I already mentioned, the most important feature, in my opinion, is that it treats tests as pure values. So what I mean by this is that if you look at the definition of the base suite, basically it consists of a type that will be the test value produced by the body of your tests. And tests in MUnit are simply a sequence of those generic tests. Knowing about this underlying fact is quite helpful if you want to tweak or customize your tests. But like I said it before, it's not strictly required. And using FunSuite will take care of most of the things for you. So let's look at what FunSuite adds basically to the core suite. FunSuite defines the value produced by our tests as a future of any. It will also work for non-future values. And it defines a test method that offers a nice syntax to define tests. And what this test method does is it will basically simply create a new test and add it to this mutable list buffer that in the end will be used to define the the sequence of tests that our suite needs to provide. A test itself in MUnit is a class that consists of a name and a body that can have a custom result type. And there's also the possibility to add a set of text to it, which can be useful for filtering or applying transformations. And there is a location that will be passed around implicitly most of the time. And it's used to enable the jump to test and error in your test outputs. So let's look at some of the developer-friendly APIs that MUnit offers. So by treating tests as values, it gives the developer a lot of freedom to customize how you want to write your tests. And many customizations can also be achieved by using text filters and transformations. So the most minimal thing that you can use is extending an MUnit suite directly and overriding the test value and the MUnit test method. And this way you have complete freedom by restricting the type of your tests even further. Maybe you say you don't want to allow any in your tests. You know your tests will always have a result of a future string. So you can override the test value and also simply define your tests as a list of test classes without using any kind of mutable buffer or side effect. And if you do it this way, you can define your tests as a simple data structure. And if you're trying to execute any logic in your body that does not have the expected test type or will not produce the expected value, it won't even compile. And so it allows you to catch errors even earlier. This API is probably a little bit too minimalistic for end users, but it can be quite useful if you want to define your own type of suits that can then be used by your team or by other people. Another interesting thing that's not quite as minimalistic, but still very useful is filtering and transformations, which can be used in combination with tags. So you can, in MUnit, you can define as many tags as you like and give them custom names, and you can add the tags to your test cases. This is quite useful for example, for filtering when you have a test that's very slow and that you don't want to run every time you execute your tests, or it needs some kind of external service that's not available in your local test environment. You can also decide to ignore a complete suite based on either a static value or also on dynamic conditions. In the second case, you can override this method and use whatever logic you want to decide if you want to run the suite or not. To filter individual test cases, you can either provide lists that you want to exclude or include via the SPT shell, or if you want to do it more dynamically, you're free to do it in your code. You can override the MUnit tests method that will eventually return the sequence of your tests. And since the sequence of tests is just a normal data structure, you're free to filter it or modify it in any way you like. So in this example, we're using the list of tests that we get from the base implementation and simply apply a filter based on the tags. And also, we can choose to just apply those filters for certain conditions. So this gives you a lot of freedom to decide when you want to run specific tests and when not. Another useful thing that is not so well known probably from other test frameworks is the way to apply transformations to your test. So there are 3 different types of transformations. You can decide to transform your whole test suite, which is mostly used for ignoring it. For example, you can have transformations for your individual test cases. So you could, like for example, implement custom retry strategies or run a test multiple times. And you can also apply a transformation to the value produced by the test body itself. And for the example of this talk, I picked the last type of transformation, which is the value transformation. And in this example, we are going to add support for Monix tasks in addition to the future. And if we look at this example, there is one small problem. So on line 13, we define a test that does not return a future as a test value, but it will return a Monix task. And if you have used Monix before, or also if you haven't, it's not important, but the important thing is that Monix task is lazy. And this means if you don't do anything else and leave the code as it is here, nothing will be actually run. And so the exception that is thrown when we try to get a value from the database will never happen. And the dangerous thing is that you might miss it when you run the tests, because the test will not complain, it will just succeed, since it doesn't throw any exception. And one way to fix this, of course, would be to manually run the task every time we create a test. So you could add this run to future call for all your test cases. And while this might work, it's not very nice, because we have to repeat this line in every single test case. And like I mentioned before, if we forget to add it, the test will not fail. It will simply still pass, and so it's quite easy to miss this. And a better solution would be to automatically transform our test value to a future that MUnit is able to understand. And we can do this by using a value transformation. So in order to transform a task automatically, we can override this method, which is called MUnit value transformation or value transform. And there we simply add a new value transform to the list of MUnit's value transforms. And the value transform that we add, we give it a name, which is task, but could be really anything. And then inside we have to add a partial function that will basically match when to apply a transformation. And in this case, we just want to apply it when our test returns a task. And so if our test returns a task, we simply turn it into a future by adding this run to future call automatically. And once we define this value transformation, we can remove this line that we added to our test cases, and the transformation will be applied automatically by MUnit. So another feature that MUnit offers is to show you actionable test results and helpful diffs right on your command line. So its goal is to provide you with useful information that can be used to debug test failures without having to navigate into your code. So in order to help you debug your test cases, it will offer you an option to jump to the location automatically in your source code in case you need to, more sophisticated debugging that the test result does not provide. It offers you some clues about the error that you can also define manually when you write your tests. It will highlight the most important stack trace lines, which are usually exceptions thrown in your application and not like the lines of the test framework itself. And if you're comparing case classes with assert equals, it will show you a nice and colorful diff. And let's look how this does look like for a simple example. Imagine we have this test case here where we have a case class which is a cat, and when we compare two instances of this case class that have one value in common and one value is different, the test will fail, and it will show you the output in this screenshot. So as you can see here where the mouse pointer is, you will get a link to the location in test, so you can simply click on it and it takes you there. It will also show you like those 3 lines that are the definition of your test and highlight the line where the error happens. It will show you which value it actually obtained. And most useful probably in this case, it will also show you a diff that highlights differences between the 2 case classes. So there is even more to MUnit that has not made it into this presentation. MUnit also offers quite a lot of different ways to write fixtures for your tests. So you can set up resources like databases or opening a file that can be both isolated and for each test case or reused between test cases. Another cool thing is that it allows you to basically tag tests that you know to be flaky. So this means that sometimes they will fail and other times they will succeed for no apparent reason at all. And so it's quite useful to being able to tag those tests and then decide that maybe you're already aware that those tests are flaky and you still want your suite or test run to succeed, even if those are failing. It offers a plugin that can be used to upload the reports produced by the test to Google Cloud Storage, so that the historical data can be used to generate reports that give you an overview of how your test cases have performed over time. And those reports can also be used to generate HTML report with MDoc. And also there is like a lot of more examples that interesting things that you can do with MUnit, and I really invite you to take a look at the website and the blog posts, because there, you can find a lot of examples. And this takes me to some credits for this talk, and also where to get more information if you're interested. So first of all, MUnit is like a new or nice combination of great ideas that other frameworks had before. So the reason why it's still a new framework is that, especially if you have try to build a minimal framework, it's by definition quite opinionated. And so its uniqueness lies in offering a combination of features that you might know in somewhere or another from other frameworks, but not like in this combination. And like I said, there is already a really nice website and a blog post, a couple of blog posts actually. And yeah, if you're interested, go there and have a look. That's it for my talk today. I was actually a little bit faster than I expected. I hope you enjoyed it. And if we have any questions, I think there are still a couple of minutes left now, or we can catch up in the QA room. Thanks.
Okay, thanks very much, Petra. It was a great overview of MUnit. There are a few questions, so as you said, we've got time. I'll put those to you now. So the first one is, does MUnit allow you to be able to consolidate reports from multiple users in its reporting?
Sorry, could you repeat it again?
So does MUnit allow you to consolidate multiple reports from multiple users in its final reporting?
By users, you mean, could the person clarify this a little bit, or is it not?
I'd like them to, yeah, but they haven't done so far. Let's put that on pause for a second, then we can.
I think you can define when you set up the plugin a certain key for your reports, and it will accumulate all data for this key in the specified cloud storage. So as long as multiple users are using the same key, it should be accumulated.
Okay, cool. Another a bit clearer question. How would you convince someone to migrate from, say, Scala test to MUnit, and how much is the migration taken into account the migration cost?
I think a big role in this question plays, an important question is which kind of tests your team currently uses. So if, like you might know, a Scala test offers quite a couple of different test styles. And I think MUnit is closest to the I think it's also called fun suite in Scala test. So if you use that suite, it should feel pretty familiar. Also, an important point is if you make heavy usage of the DSL that Scala test is using, and if you actually like this DSL, then maybe Scala test is a better choice for your team, because MUnit does not try to provide a DSL that covers every possible use case. It has a very small set of assertions. I guess it's like 5 or 6 of them. So it's very easy to know the whole API by heart, while Scala test is offering like a lot more features. But for some people, some people prefer a more minimal approach. So.
Okay, cool. I can't see any other questions right now, so I'll publish the link to the breakout room in the chat. If you could follow that, and then people should be able to go and join you there and have a bit of a more interactive QA. And yeah, thanks very much again, and thank you to your neighbors for helping with their part.
Yeah, I'm sorry about that. It just started.
No worries.
When I gave the talk. Okay, yeah.
All right, thanks very much.
Thanks, bye-bye.